Alright, so this is the video on how to do the lab. Make sure you go to classwork tab, you go to the lab topic, and then you click this lab right here. And so when you click the Google Doc, what you'll see is this sheet. Now, this lab is on how to do map scales. How to do map scales. And so what we're gonna do, we're gonna watch this YouTube video first. Again, this took place over 4 days. So we're gonna watch this video. Sorry about that. That was from the YouTube video. So what they're talking about right now is you see Gulf of Mexico, and you see this bar. And what this means is that the distance on this map, these lines indicate was the length in real life. So on this map in particular, if you take this entire bar right here, this length on your map in real life is going to be 200 kilometers. If you're taking a look at the bottom one, right, this orange bar and then this white bar. And so from this orange bar to white bar, well, that's 200 kilometers. So again, what this person is doing is they're tracing this scale onto their index card, and obviously we use meters because we are using the metric system. So what this person is doing right now, and this is a good point to just copy this picture. Let's actually just make this picture a little bit bigger. Sorry guys, let me just edit it a little bit. So let's say you have this picture right here. All right, let's say you have this picture right here. And now, well, you have the index card, right? You have the scale. On your scale, it says, well, this length on this map is equal to 200 kilometers in real life. Well, what does that mean exactly, right? So let's try and figure it out. So from this Memphis dot right here to Little Rock, that's 200 kilometers. Right here, it's 400 kilometers. And this person in the video, they want to go from Little Rock, Arkansas, to Charlotte. So they want to know, how far away is Charlotte from Little Rock? How far away is that in kilometers? Well, clearly your scale on the bottom, when you traced your scale, it doesn't go further, right? It doesn't go further. So what do we do in this case? Let me change the color actually. Red is better. So what do we do in this case? Well, what the person in the video is going to do is that they're going to move their index card over, right? Because we know that each bar is 200 kilometers in this case. So they're going to move the index card over, and now the index card is going to start at 0. It's going to be 200 here, and it's going to be 400 here. Now that's another 200, and this is 400. Now this is 600 kilometers, and this is 800 kilometers. Right? Because if you're bringing this index card over from 0 to 200, you're just adding another 200 kilometers. So if you're adding 200 kilometers to 400 kilometers, you're going to get 600. And then this is going to be 800. Well, then what do we continue doing? Well, we make sure to mark this location. Just like how we marked it over here. We marked this location. So now that we've marked this location, what we're going to do is we're going to move the index card over again, and that's what the person in the video does. And so now it starts at 0, and this is going to be 200 now. And so you add another 200, well, that's 1,000 kilometers. 1,000 kilometers. So now what you've done is you successfully made a scale. You've traced your scale over this distance from Little Rock, Arkansas to Charlotte, North Carolina. And you've measured it to be 1,000 kilometers. And I'll let the person in the video explain what I just did. And so again, because the index card doesn't go further, they're gonna move the index card over, right? Because they made the mark with their pencil. They move the index card over from the 0 to the pencil, and they continue measuring. Alright, cool. Anyway, so hopefully that was enough of an explanation. So what I'm going to do right now... Okay, I can't just copy paste this. Well, I'm going to do it right now. Do that. And so... So what I've done is just took a screenshot from Google Maps. You'll see on the bottom here, this is John Adams. John Adams. Well, how do we draw vectors? Right, you guys know what vectors mean. Vectors mean have both magnitude and display and direction. But how do we draw them on a map? Well, you draw them on a map by representing them as an arrow. The length itself is the magnitude, right? That's how large something is. And the arrow represents your direction. That's the direction, right? As both magnitude, which is the length of this arrow, and the direction, which is the arrow sign. Okay. So now what do we do? Well, on this map, it says draw a vector showing the displacement from where you go to John Adams High School to the Rockaway Boulevard A train station. So the A train station on your Google Maps, the staircase to the A train is somewhere over here. And John Adams is somewhere over there. And so if we draw a displacement, we draw this straight red line. Now imagine it's straight, right? Imagine that it's a straight line. It's a fairly straight line. And so this is your displacement. Your displacement is how far you are from your original location, right? This is your displacement, your final position minus initial position. Remember, displacement isn't the way you actually went. It's a straight line connecting the points. So you won't necessarily walk the exact path of the vector if you're going from John Adams to the A train. In physics, we use the word velocity to describe the speed of an object, but you also specify a direction. So let's say this kid named Jason, he attends John Adams High School. And it takes Jason 7 minutes to walk from the school to the A train. The A train is 420 meters northwest of the school. What was his average velocity? And show your work. Guys, I told you how to calculate average velocity. I told you guys how to do it. Average velocity, according to your reference table, is V bar is equal to D over T. Right, displacement over time, right? If this is velocity, and velocity is a vector, and velocity is a vector, meaning it has both magnitude and direction, that must mean that this D right here must mean displacement. You must use your vector versions of these quantities. And so it says an A train is 420 meters northwest of the school. So we're going to say 420 meters. And the time it takes. Well, we're not going to divide it by 7 minutes because we want it in seconds. Right? We measure velocity here in meters per second. If our time is 7 minutes, and each minute has 60 seconds, well, we're going to do 7 times 60. And we're given 420 seconds. So that's T. And so what we're going to get here is we're going to get an average velocity of 1 meters per second. And we need a direction. And we're just going to write northwest for now. And that's how you calculate average velocity, right? Average velocity is displacement over time. Now let's go on to the second question. Can you tell from the previous question whether Jason walked straight there or whether he took a detour? Can you tell where he speeds up or slows down? Well, let's think about it. There's no way Jason can walk this straight line, this straight path. he doesn't go through all of these buildings. He doesn't go through Bowl 360. He doesn't climb over fences. He doesn't go through someone's kitchen. He doesn't go through someone's living room. He doesn't go through cars. So no. He probably took a detour. He probably walked along the street like a normal human being. So that's how you answer this question and how you justify it as well. You don't need to answer this part. And can you actually you do? Can you tell whether or not he speeds up or slows down? No, you can't tell whether or not he speeds up or slows down. You calculated for average velocity. In the problem, you calculate for average. You calculate for average velocity. Oh wait, that's not the formula for average velocity. This is. You don't know. Your speed might be 8 meters per second at one time. At another point in time, your speed might be 125 meters per second. But you don't know your speed. You could be running. You could be walking along this path, along this detour, right? You're taking a detour. So you don't know what your exact speed at every second is. You know what your average speed is, or rather your average velocity is. But you don't know if he slowed down or sped up throughout his time walking to the A train station. And so that's how you answer this question. So now let's go to this image right here. And it says, on your Google Maps, locate John Adams High School and locate the nearest A train station. And then what you want to do is you want to draw the displacement between the A train station and John Adams High School. So let's do that. So this is John Adams. And the A train like staircase is somewhere over there. And that's the A train. So we want to figure out how much. So we want to figure out how much. We want to figure out how long this displacement is in real life, right? How far away is John Adams from the A train station? Well, how do we do that? Well, you see on the bottom right-hand corner of Google Maps, you see this scale. That's how much this distance is in real life. I mean, not in real life. On a map. On a map, this length is equal to 100 meters. Now, if you go to Google Maps normally, what you're going to see is that, well, this right here is going to be like 200 feet or something. Well, to change this to the metric system, all you need to do is click on the number. Click on this number right here, and you'll be able to change the metric system. So click on this number just one time, and you'll change it to the metric system. So now what do we do? So what I'm going to do right now is I'm going to trace this line on a piece of paper, right? This straight line. And after you put this line on a piece of loose leaf, for example, right, let's say you draw this on a piece of paper, let's say this loose leaf, and you successfully traced this entire displacement. Well, what now, right? Because right now you just drew the length. And then what we're gonna do now is you're gonna match this loose leaf to the scale on the bottom right here. So you're gonna mark the scale, right? Because this is 100. You're gonna move that paper over. You're gonna mark another scale. Keep marking your bars, and then you'll find out your distance. So let's say this is 100 meters, right? So let's say this is 100 meters. And this would be 200. This would be 300 meters. This would be 400. And this would be 500. Right? Because that's the length of this displacement. If you were to use the scale and draw across this line, this would be your total displacement. Right? Because there are 5 bars across this line. You're tracing your scale bar and you're coming up with 5 bars. Now, this is an estimation. What I just did here is an estimation. And so I want you guys to do this yourself. Right? So now we come here, right, on the edge of a piece of paper, mark where John Adams is and where the A train is. And we're going to skip that. Again, the scale bar is here. So using an index card, mark the length of the scale bar and label how many meters or kilometers that is. We use 100 meters, so that's our scale. And 5 of these scale bars, if you look at question number 4, approximately how many of these scale bars fit in between John Adams and the A train station? Well, it's 5 scale bars. And then it goes on to say that multiply the number from the previous step by the amount of meters each scale bar represents, right? In our Google map, each scale bar represents 100 meters. And if we have 5 scale bars, well, 5 times 100 is 500 meters, northwest. Displacement is a vector. Now, number 6. Plot a trip from John Adams High School to the A train station. So what we're going to do right now is we're going to go to Google Maps. And I'm going to search John Adams High School. And I want to get to the A train. Right, I'm just going to click the A train. Yeah. And we're going to click walk. So now you see my screen, right? You see Google Maps. And you see on the bottom right here, the bottom right hand corner, you see meters. If you want to change between metric and imperial, you just click the number. So click the number to change it. So again, that's the A train. So again, you go to walking and you want to make sure you click it to kilometers, okay? So in the options, if you're walking, in the options, click kilometers. Go to options, kilometers. Now, according to Google Maps, it will take you 7 minutes to walk to the A train station. And the distance that you take is 550 meters. So how much time does it take? Does Google say the trip should take? It says the trip should take 7 minutes. And that's 420 seconds. And now we want to divide our displacement by time and get average velocity. Again, this right here, this number right here is not displacement. That's distance traveled. Displacement, on the other hand, is the straight line from your starting position, your initial position, to your final position. This is your displacement. This number right here, that's your distance traveled. Right? This is your distance traveled. Whereas displacement is just the length in between your initial and your final position. So we calculate what our displacement was. Our displacement was 500 meters, right? If we were using the scales. Now, now we divide displacement by time and we get average velocity, right? Because we know that the formula for average velocity is v bar is equal to d over t, which means if our displacement is 500 meters and our time is 420, we should get some number. So we get 1.2, 1.19. 1.19 meters per second northwest, because velocity is a vector, and vectors need direction. Now, what is the travel distance stated by Google? Well, the travel distance stated by Google is 550 meters. 550 meters. Well, average speed, the formula for average speed, right? So it's the same thing, except if you're using speed this time, you have to use distance divided by time instead of displacement divided by time. Here above here, right here, what this was velocity. And if you're doing velocity, you have to do displacement divided by time. And they're two different things. So our distance is 550 meters. So if it takes us 7 minutes, 550 divided by 7 minutes is 1.30 meters per second. And because speed is a scalar, scalars don't have direction. We don't care about direction, so it's just this number right here. So you do the same exact thing, right? You draw a scale. Make sure you get the correct units. You need the right scale. So the average speed here, make sure you don't do that part, right? We don't want to do average speed. So don't do average speed, skip the average speed part. But every other question is the same. You pick a point, you pick a destination, and then you record how much time Google says the trip should take. You measure the scale, right? You do the same thing I did here, right? You make a scale, you draw the displacement line, and you make the scale. Remember, you have to be in meters. So you do the same exact thing for every other question.